This is a quick recording about proportions, which is located in section 7.7 and 7.8 in your textbook. Okay, we've already studied a ratio. A ratio is a comparison between two things, often represented by a fraction. Now, a proportion is just an extension on that, so it's in a statement of equality between two ratios. So it's an equation that states that two ratios are equal or exactly the same. Here's an example of a proportion. In this case, we know that these two fractions are equal. And in order for them to be equal, n has to be a specific value. Now let's take note of something. We know that, okay, in order to get from 9 to 3, we would have to divide 9 by 3. Okay, well, if this fraction here is equivalent to 15 over 9, then we must do the same thing to the numerator. 15 divided by 3 is 5, which means that n would have to equal 5. And now we know that 5/3 is equivalent to 15/9. This is a correct proportion. This proportion is true. Okay, now let's look at a different one. In this case, we know that there's a proportion that's already set up for us, and we want to figure out what n is again. Now there really isn't a clear number to multiply 2 by to get to 3 or to divide 3 by to get to 2. So we can look internally within a fraction in order to figure out the relationship between the numerator and denominator. Okay, well 3 times 3 is 9. So that means that 2 times 3 has to be the value of n, because the relationship between the numerator and denominator of the ratios in a proportion have to be the same. So if 3 times 3 is 9, then 2 times 3 has to be the value of n. Therefore, n equals 6. Okay, now sometimes things can get a little bit tricky, right? So sometimes you don't see a relationship like you did in slides 2 and 3. You don't see a relationship between the denominators and numerators, or internally within a fraction. So if that happens, you use something called the cross products property. And what that means is if you multiply these two values, so in this case I'm calling them b and c, so b times c, it's always going to equal the product of these two values, a and d. Now let me do an example so that it's a little bit more clear. Let's see. Okay, so here's this proportion that's already set up for us. We have 5 over 6 is equal to 2 over m. Now, I don't see a really clear relationship that exists between 5 and 6. I can't multiply or divide by whole numbers to get the other. And really 5 and 2, I don't see a relationship that's really easy for me to see. So I'm going to use the cross products property. And what that means is if I multiply 6 and 2 together, so 6 times 2, it's going to equal 5 times m. Okay, well you guys have already studied one-step equations, so you know how to solve for m. Now let's simplify. 6 times 2 is 12, and that should equal 5 times m, which is 5m. This is a one-step equation. 5 is your coefficient, so you multiply by the reciprocal. I'm going to do the one step in black. Okay, now our new coefficient is 1, and now I multiply it to the other side as well. Remember the equality property. So we're left with 12 over 5 is equal to m. Okay, now this wasn't a clear number that you could see right off the bat. You didn't know that m was, oh yeah, obviously m's 12 over 5. That's not something that's very clear and obvious just when you look at it. So this is a case where you would use the cross products property. Okay, the next example that we're going to do is a word problem, and we'll use the cross products property in order to solve for the answer. Okay, so if a car uses, this is our nice little car over here, zoom zoom, uses 5 gallons of gasoline to travel 160 miles, I'm going to underline the important information. How many gallons would the car use in traveling 96 miles? Okay. There's no proportion that they've given us. They've just given us information. So let's set up the proportion. So we have 5 gallons of gas this car uses for every 160 miles. Now we want to figure out how many gallons. So gallons, since gallons was used in the numerator, we're going to keep that constant. Since 5 gallons was used in the numerator, 96 miles is going to be in the denominator. See how miles and miles match up? So gallons and gallons should also match up. I'm going to call G number of gallons when traveling 96 miles. Okay? Because G is an underused variable in my opinion. Okay, so now we're going to solve using the cross products property. We could look for an internal relationship between 5 and 160. Yes, but hey, I want to practice the cross products property because that works every single time. So let's multiply these two numbers together. 160 times G is 160G. And 5 times 96 should be on the right side of the equation. 5 times 96. I'm going to do my multiplication off to the side so that I don't get my work doesn't get messy. 96 times 5, we've got 30. 9 times 5 is 45, plus 3 is 48. So we're left with 480 has to equal 160G. Now again, we have a one-step equation, which is really nice because that means that we just multiply by the reciprocal of the coefficient since we have a coefficient. Okay, so let's multiply by the reciprocal of 160, which is 1 over 160. To both sides of the equation. Okay, let's see. I wonder, I bet 160 goes into 483 times. I'm going to check. If it doesn't, that's okay. But we got 18. Oh, look, it does. That's really nice. So that means that G has to equal 3. And, of course, I'm going to label my work. So we're labeling it in gallons. So that's 3 gallons, which means that over the course of 96 miles, this particular car, the Zoom Zoom car, will need 3 gallons of gas. Okay, now you may begin your work.